Allora, per capire bene appunto questo momento straordinario che stiamo vivendo e di cui l'azienda NVIDIA è diciamo, il cuore, racconto una piccola cosa che ho visto in Arabia Saudita. Sono andata in Arabia Saudita dove è l'unico governo che ha potuto comprare tante schede di NVIDIA quanto possono comprarne i privati, e loro hanno creato un sistema di educazione per le scuole che vanno ad applicare adesso da quest'anno, in cui ogni singolo studente ha una sua intelligenza artificiale verticale sfidante, che sfida lo studente nelle materie in cui è più carente, e quindi lo accompagna lungo tutto il suo percorso di crescita. Invece di arrivargli le notifiche all'ultimo video di Fedez, gli arriva la notifica di matematica perché lì è carente. E mi hanno raccontato insomma, tutto questo progetto che hanno fatto con questa Allam, che è la loro intelligenza artificiale verticale. Poi ho incontrato qualcuno che con la sua intelligenza artificiale verticale è entrato in un'azienda e l'azienda prende le intelligenze artificiali di ognuno e, così come avviene anche in Cina, lo valuta per assumerlo prima dalla sua competenza nell'utilizzo dell'intelligenza artificiale che dal livello, diciamo, dell'università da cui proviene. Quando poi entrano nell'azienda, la loro intelligenza artificiale entra in quella verticale dell'azienda, che in quel caso è anche allineata con il governo, ma questa è una peculiarità, diciamo, di quel paese. Ecco, alla base di tutto questo design c'è la possibilità di avere naturalmente il nostro premio dei poster, cioè la scheda e il chip di NVIDIA, e questo per introdurre il prossimo speaker, che è Rod Evans, EMEA VP, High Performance Computing e AI di NVIDIA, che si occupa proprio di supercalcolo, istruzione superiore e intelligenza artificiale per Europa, Medio Oriente e Africa. Un grande personaggio che lavora da 30 anni nel settore IT, risiede a Londra, viene da altre aziende importanti come Intel, ma si occupa proprio, diciamo così, di potenziare le varie realtà in un momento storico come questo. Prego.
That's a good start. My God.
Hello, I'm James, a digital human.
Your hemoglobin A1C was at a healthy level.
Buongiorno a tutti. It's a great pleasure for me to be back here with Quattro again in Milano, do another keynote, another fantastic event. I've got a lot of material I'm going to cover today, so I'm going to move through things quite quickly. I've probably got too much material. Cosmo always has kittens when I come on the stage because he gives me 20 minutes and I take 40. But we'll see what we can get through as quick as we can. So I'm going to run through a little bit of an update today. I'm going to talk a little bit about an AI update, about what's going on in the world with a few interesting examples. We're going to talk a little bit about momentum in Europe towards gigafactories, the latest big technology term that's coming out all over the world, and also talk a little bit about what's new at NVIDIA. We made a ton of announcements in the last month or so I wanted to run through some of that with you because some of you may not have seen the new things that we're bringing to market. So let's start by looking at where we are in the AI world. The AI world really started to happen in 2012 with the launch of AlexNet, the world's first large language model, really. And beyond that, then we've gone through various phases. Over that period, we've seen the technology improvements in terms of the number of parameters in a model, the number of performance and everything else. I hate this mic, by the way. I'd rather use that one. Other advantages that are coming on. We've seen this improvement doubling every 6 months. Now, if you take that through over a decade, that's a 1,000,000x improvement in terms of complexity and in performance. To put that in context, in the best period in the computing world with CPUs, we saw a 100x improvement in a decade. So you're going from 100x to a 1,000,000x improvement. And we've seen things change through basic perception AI. The world is transformed to a better place that people can go out and build little dolls on ChatGPT of their neighbors and friends. It's a real breathtaking step forward, but actually the technology behind it is really significant. We've gone through generative AI, now through agentic AI, improving customer service and other applications, through to the next level, which is going to be physical AI in terms of autonomous driving and robotics. Now, if we look at where we are, we've seen various scaling things happen. We've seen pre-training scaling, post-training scaling, and now into test time scaling, providing long thinking. And one of the things that Jensen Huang went through in our keynote in March at our GTC event was we're now in the area of reasoning AI inference, where the AI models can go to the next level and do reasoning to give you an answer to your question in a much more efficient manner, providing a 100x improvement on what we had previously in terms of getting you the response you need. Now, the net impact of this is we're now starting to see AI appear for every industry. We'll talk a little bit about robotics and AV and manufacturing. We're starting to see now the emergence of edge computing and 6G, through to things coming out in enterprise IT with agentic AI, and also GPU clouds and cloud service providers providing much more sophisticated and complex models and things available to the marketplace. Now let's look at what some of those things have happened. One of the things that's really happening right now is we've seen a big transformation in automotive. In one of the diagrams here, you see a factory. With the move towards electric vehicles, every automotive company in the world is having to rethink their factory. It's no longer having just-in-time components to build mechanical environments. They're having to redesign and rethink the factory, using digital twins to enable them to do it. And we also started to see the emergence of autonomous vehicles. Now, people have been talking about autonomous driving forever. Anybody who saw some of the movies that have come out in the past have seen robotic-driven cars and gone, yeah, it'll never happen. Well, it actually is happening. And I'm going to show you a little video from Waymo, which is one of their promotional videos that shows how it works.
Well, it's finally happening. The robots. They're coming.
Hi, Avery.
Maybe that's a good thing.
She said what? She said what? What? I was ready like a full 20 minutes beforehand. What are you talking about?
We are now connected to our plans. It's not even
No, stop.
It drives better than you do, babe.
Who does? Bye, robot.
Now, if you manage to be in a Waymo in San Francisco or in Silicon Valley or in Phoenix, Arizona, and now also in Abu Dhabi, it is a game-changing experience. It's a little unnerving when you first get in there and it just drives off. But what is interesting from it is when I was in Arizona recently, a friend of mine's wife was saying, you know what, I choose to take a Waymo as a preference because there's no driver. Well, why is that? Because I feel safe. And people are saying, I send a Waymo to pick my kids up from football training because it's safe. They're going to get home. And it is a substantive change. And once you've been in one, you're totally sold on what it can do for you. I still remain to be convinced it's going to get through the cobbled streets of Rome with the traffic, but we'll wait and see. But it's certainly here and arriving. Next thing I'm going to look at is how we transform healthcare. One of the sad things in life as we get older is we have an aging population in Europe and many parts of the world. And in order to meet the requirements of that population, we have to improve the way we can do healthcare. From doing drug discovery and improving drugs to also providing personalized and timely medical care. Let's see how that works in reality with AI.
Hi, Sarah. I'm Rachel, your AI care manager. How are you doing after your appendectomy? You know, I'm good. I'm glad to be home with my dog, Dennis.
It's great to hear that you're back home with Dennis. I noticed that Dr. Chang has prescribed you some antibiotics, specifically ciprofloxacin and metronidazole, due to your ruptured appendix. Were you able to get these medications?
I was. I did forget to mention to the doctor that I am allergic to penicillin. Is it still okay to take the medications?
Great question. The antibiotics you've been prescribed, ciprofloxacin and metronidazole, don't contain penicillin. So it's perfectly safe for you to take them. Can you begin taking them today?
Yeah, I certainly can. Do you have any tips for faster recovery?
Given that you have diabetes, keeping your blood sugar levels in check will be beneficial for your wound healing. Your hemoglobin A1C was at a healthy level of 5.5, but your glucometer readings from yesterday were a bit on the high side. So keep taking your metformin and try to steer clear of foods high in carbs. How does that sound to you?
I think I'll be able to avoid the carbs for the week. You know, I need to go right now, but it was great talking to you.
I'm glad we had this talk. I'll pass along your progress to Dr. Chang.
Goodbye.
Goodbye.
And it may sound like this is fantasy, but this is reality. If you saw the picture of me at the beginning, the very unflattering picture from a year ago, I've lost 40 kilos in the last 10 months. And I've been doing that with a weight loss program. And one of the things I have with that is an AI program I can talk to 24/7. And it can give me advice and guidance. Rather than me having to book a clinician call, I can do it all with the AI tool. And it's got so good now that I never talk to the clinician. I do everything through the AI tool. So this is definitely going to transform healthcare across the world and certainly help us in managing our aging populations in Europe. Let's move on to the next thing. Physical AI we've talked about for a while, and everybody's seen the jokes about robots, but they're actually happening. So I'm going to show you a little video now showing you the progress that's being made in making robots and robotics better to help us manage things like manufacturing and other parts of our lives.
The age of generalist robotics has arrived, with breakthroughs in mechatronics, physical AI, and embedded computing. Just in time, as labor shortages limit worldwide industrial growth. A major challenge for robot makers is the lack of large-scale, real, and synthetic data to train models. Human demonstrations aren't scalable, limited by the number of hours in a day. Developers can use NVIDIA Cosmos Physical AI World Foundation models to amplify data. Groot Dreams is a blueprint built on Cosmos for large-scale synthetic trajectory data generation, a reel-to-reel data workflow. First, developers fine-tune Cosmos with human demonstrations recorded by teleoperation of a single task in a single environment. Then, they prompt the model with an image and new instructions to generate dreams, or future world states. Cosmos is a generative model, so developers can prompt using new action words without having to capture new teleop data. Once a large number are generated, Cosmos reasons and evaluates the quality of each dream, selecting the best for training. But these dreams are still just pixels. Robots learn from actions. The Groot Dreams blueprint generates 3D action trajectories from the 2D dream videos. This is then used to train the robot model. Groot Dreams lets robots learn a huge variety of new actions with minimal manual captures, so a small team of human demonstrators can now do the work of thousands. Groot Dreams brings developers another step closer to solving the robot data challenge.
There's no question you are going to see humanoid robots appearing in 2026. We know some of the plans coming out of Japan and other countries, they will be here, and they're coming at the right time. One of the challenges with the manufacturing environment is workforce absenteeism. People find your manufacturing tasks very boring and laborious because you do the same thing a million times a week. Being able to robotize that means you actually can make sure you can maintain production, but you still have the human intelligence driving what the robots are doing. So it's actually augmenting and helping us get a better world. Now, we're starting to see this concept of the AI factory, and I'm a bit tired of talking about AI factories now, but when you see some of the things that are going on there, you can see what it is doing. It is now basically a data center producing tokens or units of intelligence, and that is going to be driven by these new wave of AI agents and robots using our new technology through this new infrastructure with a 10x improvement in European infrastructure in the next 2 years. Now, Europe has been a little bit behind the curve, but not any longer. Back in February, the EU finally started to take AI seriously. It launched an AI action plan with an AI continent plan, the AI factory launch, AI gigafactory expression of interest to make sure that Europe gets its fair share of the marketplace and is not completely dependent on China and the US. We started to see the European Union announcing these 20 or 30 AI factories, including one here in Italy at Cineca, where the RFP is hopefully going to be out this week, so they tell me, maybe next week, but it'll be out hopefully soon. But we're starting to see a number of these come across Europe, and we're expecting to see something like 5 to 8 gigafactories announced by the European Union within the next 12 months. NVIDIA is supporting on these processes both things. We're supporting the EU in understanding what a gigafactory and AI factory means and how to implement it, but we're also supporting the bidders, making sure they can build credible bids to make sure that Europe can be at the forefront of this technology provision and not be dependent on US hyperscalers and US entities or other European entities to make sure we can deliver the service for European business and public sector. So we're going to support both of those to make sure that we can actually provide it. And as you'll see from the announcements a few days ago with NVIDIA investing with OpenAI and building new infrastructure, we're going to use our balance sheet to put a lot of effort in there to make sure that we can maintain this going forward. And we've been building these AI factory models. They really depend on a reference architecture, which we've been spending a lot of time working at, how you can improve performance, how you can improve training, how you can improve throughput, improving time to market for tokens in these environments to get these new applications out there. And the slide presented recently by Jensen Wang at our GTC in Paris, we're expecting in 2026 to see a 10x growth in European deployment of AI technology. So it's dramatic growth in a short period of time. So Europe is now getting on the map, and it's great to see, and Italy will be at the forefront of that along with some of the other countries like Germany and France. So what's new from NVIDIA? Now, this is the bit where I go a little bit over time because I've got a ton of stuff to present, but it's really good stuff. So I've got to spend some time to share it with you. So, press the wrong button. Go back, try again. No, it doesn't work anyway. So NVIDIA's been transforming applications with CUDA and with our libraries for a number of years to making it easy for people to transform applications. We're now bringing in new areas. One of the things we're bringing in, and my colleague later will be talking about this morning, is we're bringing new things into classical computing and quantum computing by using CUDA-Q to bridge the two between classical and quantum. And this is the first of a factory of announcements that NVIDIA is making on the quantum side. We've got a number of announcements here. QUantum is a quantum algorithm development capability, giving an 800x speed up against CPU. We can also help with qubit designs at 1200x improvement and quantum data generation with 4000x improvement. Q2Q that was on the last slide gives you improvements in terms of hybrid applications as well as quantum error correction. Yeah, quantum computing is one of those things like fusion energy and robotic vehicles has always been 10 years away. Oh, it'll happen in the next 10 years. I think it's going to accelerate much quicker than that. And you're already starting to see robotic vehicles. Fusion energy is likely to be next, but also quantum computing in that period of time, which will transform the way we can assimilate large quantities of data. What about what we're doing with AI? So NVIDIA's Blackwell platform has been out now for a while. It's based around this building block of 1 CPU and 2 GPUs, and it's giving you huge improvements in terms of the reliability, a lot of transistors, our 2nd generation transformer engine, and our 5th generation of NVLink connecting all the GPUs together. And we're starting to see some dramatic improvements. So here you'll see on this next slide, on the left-hand side, you'll see a 350x energy reduction in 8 years to train a 1.8 trillion model with ChatGPT-4. So from up the top there with the Pascal generation, 2016 to where we are, we've seen this huge improvement. But on the other side of this, you've also seen a 1000x improvement in compute. And our next generation, which I'm going to talk about in a minute, is going to take that off the chart again with a much more dramatic improvement in late 2026 and early 2027. This is our biggest machine today. It is the GB200 NVL72. It's 72 GPUs all interconnected to effectively create one giant GPU with 720 petaflops of performance on FP8, a lot of performance in inference, multi-node all-to-all, 130 terabytes a second, and a huge capability for all reduce on big data problems, a 36x improvement on the previous generation. We're shortly going to be launching our GB300 NVL72, which gives you even more improvements on the H100 generation, which was only launched 2 years ago. We had 100 tokens a second. Now we're going to be 1,000 tokens a second, reducing the time to process from 1.5 minutes to 10 seconds. And this is coming out right now. It's based on the Blackwell Ultra chip, which gives you 1.1 exaflops of FP4 performance, 1.5x times our current GB200 capability, 2x improvement in instructions, 1.5x improvement in memory, 2x improvement in networking, 140 kilowatts a rack, directly liquid cooled, giving a sustainable solution for the world to be able to do these large models, to be able to drive AI. Now, beyond this, we're starting to see lots of complexities come with inference. A lot of the AI talk about being about building and training big models, but built models don't do anything until they're doing any inferencing with real applications. And we're starting to see the AI factory being pulled into 4 or 5 different directions. How do I get more intelligence, be better response, reducing my cost, getting my throughput, but also improving energy efficiency? So one of the things we're trying to do is when you look at inference, it requires what we call a smart solution. Scale and complexity, the ability to do multi-dimensional performance with a scalable architecture and software, giving you a return on investment with a technology ecosystem and install base. And around that, we're providing all the building blocks. The NVL72 we've talked about, providing this one giant GPU, our Spectrum-X Ethernet, now the highest performance Ethernet on the planet, lots of capability with NVIDIA FP4 acceleration, Dynamo, our new dynamic improvement in data management. The Blackwell ROI is now 10x. And we're making all of our software available open source, as well as being from NVIDIA. If you want fully supported, go ahead. If you want open source, it's also available for you. Beyond that, next year, we're launching a new CPU, our Vera CPU, which is going to give you basically 2x the performance of our Grace CPU, twice the memory, twice the energy efficiency, 7 times faster GPU connectivity, and available in the second half of 2026. And allied with that, we have a new GPU. Our Rubin GPU, we were able to do 576 GPU dies in a single rack, 2,304 memory chips, a lot of NV link switches, lots of transistors, huge performance improvement. The first thing we're doing with that is the NVL 144, which gives you 144 GPU dies in a single rack. You can see on the GB300, I talked about 1.1 exaflops. With this generation, we're going to be at 3.6. So 3x improvement in that. So 3.3 times the GB300. 1.4 petabytes a second of HBM memory. But they're going to be up to 250 kilowatts a rack with direct liquid cooling. So it's going up in the rack density as well. And in early 2027 or second half of 2027, we'll be launching our Rubin Ultra GPU. 4 GPU dies on a single chip, providing up the capability to 576 GPU dies inside a single rack, 15 exaflops. If you go back to the previous slide, we're at 3.6. With Rubin Ultra, we're going to be at 15 exaflops in a rack, right? 650 kilowatts per rack, available in second half of 2027. This is how we keep AI and sustainability working together, providing very high density in a rack for everything's around this. Now, inference is also changing. We're starting to see new use cases coming in, where you've got lots of small, medium context, lots of simple things. But we're also starting to see problems where you have large contexts, million-plus requests, a lot of high value going with it, and that's including advanced coding and also video processing and generation. Now, in order to do this, inference is starting to become 2 workloads. You've got your traditional inference server where you make your query in there, it gives you a context pre-fill, and then it does the decoding to give you the answer. Now, we're going to launch the capability for you to actually do a co-processor or a co-GPU to take that decoding and put it onto a lower cost device that can actually do that in a quicker manner while reducing the cost and making it much easier to get quicker answers for inference as well. So we recently announced a new thing called the Rubin CPX, which is a GPU designed for this special inferencing and for massive content. It provides a 30 petaflop FP4, so it's not dramatically big like the Rubin Ultra, but it doesn't need to be because it's doing inference, and it's at a substantially lower cost. It uses lower type of memory and provides the capability to do generative video. It'll be available at the end of 2026. And with that, we're launching the capability to you to have these as a co-processor. So you'll see this is the Rubin 144 I showed earlier, but you'll also see, if you look on the right-hand side, you'll see some new other chips based on there, like co-GPUs, which is the Rubin CPXs, which can sit alongside the 144 GPUs in the same rack, or it can even sit there in a separate rack. So I can have one rack of 144 and a rack of the Rubin CPX alongside it, providing a co-racing either in one or two racks, depending on your ability to deploy it. Now, we're not stopping there. So these are dramatic changes that are coming in the next 18 months, but you're also starting to see a continued focus on a one-year rhythm. And in 2028, we will be launching our Feynman GPU as the next generation beyond that, with new switches again, new Ethernet switches, new interconnect with the next generation of InfiniBand and Ethernet improvement in 2028. And you're going to start to see this every single year from NVIDIA, with a new GPU generation coming every year. It's mind-blowing how that's going to change the world and how frequently people are going to have to reinvest. So some final thoughts. 2025 have been the year of generative AI in enterprise. We've started to see a lot more applications out there, a lot of people using agentic AI and everything else. In 2026, as I predict, you're going to see the rise of physical AI, but we're also going to see improvements in compute, but also in the energy efficiency of it. As you get that extra performance, we get more performance per watt. And you are going to start to see AI factories everywhere. Jensen Huang stood in front of us at an NVIDIA management team in December 2023, and he said to us, you're going to be here telling your children in a few years that you were there when the AI generation actually happened. It is going to be a transformational moment for the world and for everything. And you're going to also be sharing that journey with us. Remember to tell your children, your grandchildren, you were there. Thank you.